Good morning all, and thank you for attending our webinar today. The topic will be Big SQL Analytics and Amazon of Redshift overview, and overview of Amazon Redshift, excuse me. My name is Bernard Wavy, and I'm with StatSlice Systems. Before we get started, let me tell you about StatSlice. We are a Dallas-based analytics and business intelligence consulting company, and we pride ourselves on being experts at delivering cutting-edge analytics solutions to our clients. We partner up with several leading BI vendors, not only to deliver implementations for our clients, but also training and support. And some of the vendors that we work with are Microsoft, QlikView, Tableau, Rombi, AWS, and XLQ. As the title implies, the topic today is part of our Big SQL Analytics series. And that's our search into SQL-based alternatives to Hadoop. You can find more on this investigation at www.statslice.com. The webinar today will focus on the business use case of Amazon Redshift and the implications of this tool on BI architecture. We will not be covering the nuts and bolts of the tool itself, but more its uses. So let's start off with what is Redshift. As the name implies, it's a tool owned by Amazon, and Redshift is a cloud-based data warehouse. A very important feature of it is that it's SQL-based, and it delivers petabyte scale performance. And some of the notable notable features are it's very easily encryptable with minimal impact to performance, as you'll see in the POC today. It's extremely easy to maintain, so as simple as clicking a button can double the number of nodes, and it's very inexpensive. According to Amazon, it's around $1,000 per terabyte per year. It's important to note that this number requires so $1,000 requires a 3-year commitment. It's more expensive than that if you go by the hour or 1-year commitment. And at these numbers, at $1,000 or even at some of the higher per year commitment, it's still pretty affordable compared to traditional BI platforms. All right, so let's talk about the business use case. Most companies in today's environment, even small to mid-sized companies, are forced to deal with large data sets. Before we continue, let's define what we mean by large data sets. When we talk about large data sets, we're referring to tables that are in billions of rows. And small to medium data sets are in the hundreds of millions of rows, and extremely large data sets would be in the hundreds of billions of rows. So for data sets that are in the billions of rows, we find that more and more companies are having to deal with such sizes. And the reason for this, analytics are in wider use, data is becoming more abundant, and competition is forcing companies to keep up. And the sources for large data sets come from two primary ones. The first one is processing-intensive analytics. So this is mostly related to prediction problems. So taking data from the past year or 2 years and projecting what will happen over the next 1, 5, or 10 years. And the second, the obvious source is large data set or source systems that have large data sets, such as weblogs. What's happening is that these large data sets are causing companies to hit the limits of traditional BI platforms. And so that's when you start considering alternatives. And when you look in the marketplace and look at the most popular options for dealing with large data sets today, the one that has the biggest marketing cloud, the biggest PR, is what you hear about big data and Hadoop, or something equivalent, but Hadoop has the lion's share. And the second option that's not as popular, but you could say it's more traditional, is parallel processing tools such as Teradata and Netezza. The problem with Hadoop is that it requires expensive retooling, and it may or may not be the right answer in 5 years. And then the second option, the traditional MPPs, they're often too expensive for most small to medium-sized companies. And so that conversation is a non-starter. So the ideal solution is a Hadoop-style SQL-based tool that's inexpensive. And when we say Hadoop-style, we're referring to a tool that allows parallel processing via software scalability on commodity hardware versus your traditional MPPs. And so Amazon Redshift fits this model. It's not the only tool that fits this model. There are other, what we're calling big SQL analytics tools that follow this particular model. It's one tool I'd mentioned locally is Huge Data. It offers a similar product to Amazon Redshift. And then you also have Impala by Cloudera. So let's go over a recent case study that's appropriate for Redshift. We have a competitive internet business. The business sells monthly data subscriptions to consumers, so 10 million plus customers, and each subscription has multiple products. We have 10 plus products with varying fulfillment cost streams. So managing the business competitively requires projecting cumulative cost streams on a monthly basis for each customer. And so the projections include a 10-year horizon, so cumulative cost between month 1 and 120. And so what's the problem? Why is this an issue for traditional BI platforms? If you look at the numbers, 10 million customers times 10 products times 120 billing periods, you end up with an output of 12 billion rows. And so that by itself is possible in a traditional BI platform. However, add on top of that some additional requirements, such as a large number of the projections have to be recalculated on a daily basis. That's one. And two, full reprocessing could occur frequently due to changing projection curves. And then three, there's a short window for processing, even for full reload. And so with all those requirements, it becomes pretty challenging to build and maintain this system in a traditional BI platform. And so the situation is not unique, and there really should be an easy and inexpensive way to handle it. And the answer is Amazon Redshift or Big SQL, or other Big SQL tools that have similar offerings. Before we jump into the POC, let's just quickly define scalability. And when we talk about Redshift scalability and or parallel processing scalability, we're referring to what's known as linear scalability. And so there's no such thing as extremely accurate linear scalability. We're going to be close to linear scalability. But the problem with traditional BI platforms is that they do not offer a linear scalability. And so if you have a traditional BI platform of a size, or server of a size of X, and you double your server to 2X, your performance is not going to go from Y to 2Y for large data sets. You're going to see a diminishing return on your investment. Versus in a parallel processing environment such as Redshift, you should expect a linear increase with performance as you increase the size of the platform. So as you go from X to 2X, your performance should go from Y to 2Y. And you'll see this in the POC today. So let's go ahead and jump into the POC. I'm going to switch over to the Amazon Redshift portal. And so I'm logged into the AWS portal here, and I clicked on the Amazon Redshift cluster. Once I hit the clusters, you can see that I have built 2 clusters for you. One I'm calling large and one small. And once I click on the large cluster, I go into the details, and you can see that this is made up of 4 nodes. And in addition, I have some attributes here that are important for connecting to the cluster, such as the connection information and other attributes. And then if I switch to the small cluster, you can see that I have 2 nodes on this cluster. And in addition, I have some tabs here that I can click on, such as status. That allows me to quickly look at the high-level status of the cluster, and then to configure alarms if I need to do so. And then you have the performance tab, which shows you the key performance indicators on the cluster, so you can monitor the health of the cluster. And then finally, you have a Queries tab that shows you what's been running on the server over a time interval that you can define. And then I'd like to show you here that in terms of maintenance, you have an easy way to resize the cluster if your data volume gets bigger or you feel like you need more performance. And you can go from 4 nodes to 8 nodes, for example, or you can switch the node type from 1x to 8x. And we'll go over the difference between those two a little later in the demo. Okay, I have a question here from Jim. It looks like it's a security questions, and it's asking asking us to explain how security works. Are there security layers? So the way security works with Amazon, I'll delve into this a little bit more later in the demo. You have the ability to encrypt the data itself. So this cluster, right now, the one I have is not encrypted, but you can encrypt it in the setup. And that's going to allow you to restrict or encrypt the data at rest. And then you also have ability to configure security via AWS. You can set up a VPN connection to the cluster, as well as security groups to allow you to monitor, to maintain, and restrict access to your cluster. If there are additional questions on security, feel free to send us an email, or we can take them at the end of the webinar. We're going to have about 15 minutes for Q&A. So let's keep moving. We have quite a bit to cover. So once I have defined the cluster, the next step is to define an ODBC connection to the cluster. So what I've set up here is I have 2 ODBC connections, one to the Redshift large cluster and one to the Redshift small cluster. And then I can click in here, and I've configured the server connection, which I got from the portal, as well as the user and password. And I can click and test my connection and see that I can connect successfully. Now, setting up the connection to Redshift wasn't extremely complicated, but it also wasn't very easy. I would describe it as it took a little bit of work to configure it, but once it was done, then we were up and running really quickly on it. So once you define your ODBC connections, then I'm going to switch over to my SQL client so I can connect to the service and run a few queries. And I chose to use Squirrel SQL Client. Now, this is a free tool, free SQL Client tool. And if you do choose to go with Amazon Redshift, we would recommend that you invest in a tool that's a little bit better than this. Maybe you have to pay for the license, but it does give you additional productivity. And let me tell you about the tables we're using for the demo today. This is following the case study that I mentioned to you, the subscription business. And we've loaded 4 tables into Amazon Redshift. The way we loaded these tables was following the recommended approach by Amazon, which was to move files over to the Amazon S3 server, the simple storage server. And from there, we used the copy command to bulk upload the tables into Amazon Redshift. And I have 3 tables with me here that I'm going to be using to produce the output. And the first one is a subscription table. The second one is product. And the third one is period. And I'm going to highlight these 3 tables and just run the counts on them. And you'll see that I have the numbers here are a little different than what I showed you in the case study, but it still highlights the point. 100,000 records in the subscription table. I have 100 records in the product table and 120 records in the period table. And in order to illustrate the power of Redshift, we chose a relatively simple example to show you today, and that's using a cross-join off of these 3 tables and to produce an output that's pretty large. And cross-join is the easiest way to do so. So if you take the source data, so 100,000 records in subscription, 100 in product, and then 120 in period, and multiply those numbers out, you end up with 1.2 billion records. For during the demo, I'm not going to run that full data set. I'm going to limit the subscriptions to the top 10,000 records, and that's so it returns in a reasonable amount of time. So I'm going to highlight this query, and I'm going to run it on the large cluster first. So this is my connection to the large cluster. And I'm going to turn over to the small cluster, and I'm going to run the same query. And then I'm going to watch this run for a little bit. And again, my expected output is about 120 million records. So not extremely high, but still representative as far as giving you an idea for the power of Redshift. And then one thing to note is that at this small level of rows, you may or may not see the linear scalability that I was referring to. In general, I do see it, but sometimes I ran some queries where at 120 million records, it was giving me some variations on the amount of time it took to run. And so we see the first query came back at 33 seconds. And so I'm going to run a count on that table, on the sub-report table. And just to explain a bit about this table and the idea behind the demo, this is a typical fact table. So you have a metric, which is price times cumulative usage. And then you have some additional dimensions. And then those dimensions, once the table is produced, can then be joined back to, the dimension keys in the fact. Once the fact table is produced, can be joined back to the dimensions that we preloaded into Redshift. And so looking at the output, looks like the small cluster also finished, and it finished at about 56 seconds versus 33 seconds on the large cluster. So again, pretty impressive performance. And in order to give you a really good feel for the power, we preloaded the full data set. So what I did this morning was I ran the full data set into a sub-report full without any restrictions on subscriptions. And I did that on the small cluster as well as the large cluster. In addition, and I'll run the count here just to show you the output of that table. In addition, I ran some additional data manipulation queries on that same table by appending the same data over into that table, so 1.2 billion plus 1.2 billion to ending up at 2.4 billion. I ran an update statement of 10% of that data, and I also ran a delete statement of 10% of the data, just to highlight the capabilities in terms of data manipulation for this tool. So the count came back, took about 18 seconds, and we can see here we have 2 billion and 160 million records in this table. And so finally, I'd like to show you a few queries I built for the purposes of the demo today. And these queries are representative of what a data analyst may run on a small data mart such as this. So for example, the first query is a checksum query. Give me the count and the sum of all costs from the fact table. Here's a checksum query for period 1 only. So I'm running a where clause, returning only the data from period 1. And this is a between query, between 1 and 2, 1 and 10, and give me all the counts and then sum of all the costs. And then I ran a little bit more advanced queries, one with a join, so I'm joining the fact to the dimension, and then running a like clause on the full name to give me only the data that, only the records that start off with E. So give me every subscription that has a first name that starts with E. And then in addition, made it a little bit more complicated by adding an OR clause. So took the same query and added an OR clause to return the data only for period 1. And then finally, ran a group by query and only returned the data where the first name or the name starts with an E and then has A somewhere in the rest of the name. And so what we're going to do is we're just going to run this last query, and we're going to kick this off in the large cluster, and then turn around and also kick it off in the small cluster. And we're going to let this run on both clusters. Meanwhile, I'm going to jump back to the PowerPoint presentation, And then what I did is I ran the queries and I compiled for you the statistics, and I did so on several configurations. So not only we ran several different styles of queries, but also we did that on the 4-node cluster. So we're calling that large cluster, and on a 2-node cluster, and then on a 4-node cluster that's encrypted. And then the 4 queries that we ran were the first for insert and updates are the inserts into a brand new table, 1.2 billion rows, and then the second was an append into that same table of 1.2 billion rows, and then thirdly, update of 10% of the data of 2.4 billion rows, so 240 million, and finally a delete of 240 million. And you can see that the performance of the encrypted cluster versus the non-encrypted cluster was pretty comparable. There's some variation here in the 1.6 minute, but relatively comparable, so very little impact as far as encryption is concerned. And then the performance of the small cluster as compared to the large one is about linear, about twice as much as the 4 nodes, but not exactly so, but close to. But if you're looking at this column here, it's quite impressive performance of 4.5 seconds to load 1.2 billion records, and then about 28 seconds to delete 240 million records. And so what this shows is that not only this tool is powerful at generating data, but also it seems to address concerns when it comes to big SQL data in the sense that it allows you to manipulate data very quickly as well by doing deletes or updates. Okay, the second set of statistics that we ran were data retrieval or select queries. And we did that on the same set of 3 clusters, 4 nodes, 2 nodes, and 4 nodes encrypted. And we ran it on the output of the prior steps. So took the output of about 2.16 billion rows. And then these are the 6 queries that I showed you in the SQL client. So starting off with a checksum and ending with a group by with the advanced where clause. And you can see again the performance between the cluster encrypted versus non-encrypted is relatively similar, and about linear performance between the 2 and 4 nodes. But more importantly, is just look at the general performance of Redshift itself. 22 seconds to run checksum, and then the complicated query took about 53 seconds. And one thing to note here is that in terms of optimization and configuration, I really did not do anything on the cluster. So no indexing that I had to do. And in general, the service is configured to where you don't need to run any indexes, because that's all managed for you behind the scenes. And so extremely impressive performance, as you can see from the results of this POC. Let me pause here for a second to see if anybody has any questions. Jim, do we have any questions or anybody that needs any clarification before we continue? Okay, looks like we don't. So let's go back to the SQL client, and let's look to see if the results of the data came back. And sure enough, the first query came back, and I have about 111 records. And the large cluster came back at about 40 seconds. And then the small cluster also came back, and it took about 82 seconds. So almost double. All right, let's switch back now to the Redshift portal, and let me just highlight something before we continue with the presentation here. One thing I'd like to show you is how easy it is to launch a cluster. And so I'm going to click on Launch a Cluster. I'm going to enter the name of the cluster, so sample. I'm going to make a username, enter a password. and then hit continue. And so really another couple of forms and you're done. But it's worth it to note here the difference in the node types. So you have two options when it comes to node types for Redshift. The first one is the X large, and the second one is the 8X. The 8X has 16 virtual cores in it and 122 gigabyte of memory per node with 16 terabyte of storage, versus the 1X is 2 virtual cores and then it's 15 gigabyte per node and 2 terabyte of storage. Now I built the clusters that I built were on a large, on a 1X versus an 8X. And then what you do here is you define your nodes, and you can go all the way up to 16 nodes. And what I have was 2 versus 4. And then when you continue, something is up with my browser. And when you hit continue, you go back to, okay, it looks like we went back to the beginning, so just bear with me for a second. I'm going to go back and re-enter the password. I think may have timed out on my login. And so I've configured, I chose my node type, I chose 2 compute nodes, and then now I have the option of encrypting the database or not. And it's as simple as clicking yes here if you want to do so. And then when you hit finish, the cluster gets configured within minutes, pretty much. So let's switch back to the presentation, and let's put things in perspective. So we've seen the performance on 2 to 4 cluster. What I did just to put things into perspective was to build a 2-node 8X cluster. So this is the almost the lowest size in an 8X cluster, and the performance just increased massively. So we went from 1.2, the insert of 1.2 billion rows from about 9 minutes in the 2-node cluster 1X cluster type to about 1 minute in this environment. And then it took only 10 seconds to delete 240 million records, and then 18 seconds for the advanced group by query, or for the group by query with an advanced like statement. So extremely impressive performance, and this is only on a 2-node cluster. So just imagine what a 16-node would perform like. So let's talk about architecture implications. Given the capabilities of the tool in terms of performance as well as ease of administration and also the cost, we think you should think of Redshift today as a heavy-duty data bulldozer. So you're not going to use it for every job in your analytics system, but you are going to use it for those jobs that require very large data volumes. In the future, this view may change. So as big SQL technologies matures and as more offerings pop up in the marketplace, we see potentially the majority of analytics shifting to such a platform. So whether it's Redshift or something equivalent, but this technology with all the capabilities that it brings to the table becomes very attractive, especially as it matures. So for today, we see 3 primary use cases for Redshift. The first one is offsetting very large data sets, so billions of rows off of your traditional environment. And you can see that highlighted in option 1 here. So if you have your traditional on-site data warehouse and you could use your ETL to grab data out of the warehouse and move it securely over to Amazon's S3 server, the simple storage server. And from there, you're using a copy command, bulk load command, to load the data into Redshift. Following that, you run your scripts in Redshift and produce your analytics or run all your processing. And then you take views of that data, so aggregations, you bulk export that back into S3, and then from there move it back into the data warehouse. And so that's option 1 right now. That could be used right now to offset large processing. So take the example of the case study that I shared with you earlier. It could have been done on this side and then saved quite a bit on the design requirements for on the traditional BI platform. The second option that we see is for Power Analysts to directly connect to Redshift via a SQL client. So you have your data loaded in Redshift, you have your large analytics here, and then the Power Analyst is using SQL directly to run queries and run analysis on here. And the third option, and one that's pretty intriguing, is to run your summarized dashboards off of high-volume data sets directly against Redshift. I'd like to note here that that Tableau is one of the first tools offering native connectors to Redshift, but you could still use other dashboarding tools, but you'd have to use an ODBC connection. And we're offering a webinar on Tableau against Redshift next month, so to cover that topic. Okay, so now that we've talked about architecture overview, let's discuss some limitations. So first thing to mention is that this tool is still in beta. Now we haven't noticed any issues with the tool. It seems fully functioning, pretty stable, but it is still a beta product. I would say that even at this stage, it could be used as part of your production ETL environment. So maybe for the three cases that we outlined, but you have to proceed with caution given that it's in beta. The second limitation is that it does not allow store procedures or functions. And so that is a pretty big limitations for building if you have analytics that require processing. However, there's an easy workaround, which is to use SQL scripts for that. And third limitation is compared to T-SQL and PL/SQL, it is limited. So Redshift itself is ANSI standard, but it doesn't have all the features of T-SQL or PL/SQL. But we do expect that to mature over time. So what are the most appealing features of Redshift? Number one is its extreme scalability. So I've shown you examples here of billions of rows, but this system can go up to hundreds of billions of rows and even more. And then it requires very little retooling. So looking at other options such as Hadoop and comparing that with something like Redshift or other big SQL tools, the big benefit of such a tool would be that you could take your analysts, so if you have 30 analysts that know SQL right now, and move them over to this platform with little retooling as compared to Hadoop or other big data that require you to ramp up on Java. And it's very inexpensive. So I mentioned the $1,000 per terabyte per year. There's actually even a cheaper alternative, which is to just use Redshift on demand. So you could you can program your system or your ETL to launch Redshift and then move data over, run your aggregations or your analytics, and then take a snapshot and then turn the system off. And so thereby only paying for the hours that you use for the system. And then it delivers linear scalability, as you've seen from the POC. And then finally, it requires little maintenance, so almost minimal to no DBA involvement because all the low-level maintenance is taken care of by the system behind the scenes. Now you do have design and other considerations, but the low-level maintenance you don't have to worry about. So what are some conclusions that we could draw based on this tool? First, or based on this POC. The first thing is that it's not clear which big data approach will win in the long run. So avoid jumping in too early. Can everyone hear me okay? I'm getting a network performance issues. Jim, can you hear me okay?
Yeah, you were very clear.
Okay. All right, sorry guys. So what are some conclusions that we could draw from this POC? So again, it's not clear if Hadoop is going to win or other technology is going to win. So don't believe all the hype and marketing you hear, and avoid jumping in full speed onto one path too early. We believe, as a matter of fact, that big SQL technology and the approach that we showed here in the POC, it looks very appealing for analytics, especially for structured data, and seems better suited than Hadoop-style architecture. So as a matter of fact, I mentioned Impala, and it's an offering by Cloudera, and what that is a real-time SQL engine on top of Hadoop. So they're kind of moving towards what Redshift has done and what Huge Data has done, which is from the ground up build a SQL engine. And so, the fourth conclusion is that Redshift is one of the leading big SQL offerings in the marketplace. And so we'd recommend investigating these alternatives, big SQL alternatives, or talk to someone who has, and start a Redshift POC if you feel that's the right fit for your team. And over time, slowly integrate big SQL into your architecture. And what starting early will allow you to do is allow you to get a leg up on the competition. So as your data volumes grow and as this technology matures, you're already up to speed on it, and you could take advantage of the productivity it brings, and then and focus your effort on delivering business value versus trying to continuously re-optimize your traditional BI platform systems as your volumes grow. And so this brings us to the conclusion of our webinar today. Like I mentioned, we're going to open the floor now for questions and answers. There's no rush. We'll be here for until about noon. And then for those of you who have to drop off or for some reason don't get a chance to ask any questions, please feel free to email me at bwavy@statslice.com. All right, so it looks like we have a lot of questions. Let me, can everybody see the question pane? Let me make sure I hide the information.
I've been answering most of them, but Eric McNeil is very focused on a lot of the security aspects of Redshift in general.
Okay.
He wants to know about security layers, firewall systems, etc. He's got SQL injection in here, which is usually only from web-based systems or SQL generators. This, obviously, since you can inject SQL directly into it, you can't really protect against that. But we also had a couple of questions regarding how to schedule and set up secure uploads. You know, what is that process? They want a little more focus on the process of getting data from their system into Redshift as well.
Right. So, I mean, Jim and I both worked on getting the data over and the security. Getting the data over, you could set it up with an ETL tool. So, and Jim, jump in here whenever
sure.
Appropriate. But we have a, so you could think of a SSIS. You have an SSIS environment, and you produce your output, and you spit it out into a flat file, and those could be securely transferred over to Amazon S3 server and also encrypted. So you could have, as far as the security of transfer of data, you could set up Amazon Redshift and the whole AWS environment as part of your VPN system or as part of your network. And Jim, you may want to add to that.
Yeah, I mean, everything that's in the normal Amazon EC2 setup for security is available through Redshift or through S3 or through everything else. The basic process here for pushing data up, there's two possible ways to do it. One, the fastest way is if you export to flat files, you can push that up into S3. You can encrypt it, you can store it, and then you basically run a SQL query on Redshift to import the import that data into Redshift, similar to doing a bulk import or anything else in Microsoft SQL, etc. The other option is you can actually just make a live connection with many of the ETL tools to Redshift from your existing system and obviously secure it, but you can connect directly and do individual inserts or bulk inserts straight over an ODBC connection or something else. Obviously, that's not quite as fast, but you can get more real-time that way, and you take away the S3 step. As for security, you can push Redshift into a virtual private cloud. You can set it up so that it is basically part of your network, and only your network has direct access to it. It's not actually public. It's only internal to whatever location you're at.
Yeah, and then there's a question here about if healthcare data is housed and breached at Amazon, what happens next? Who's liable? How strong is security? So, I mean, the answer to that, we wouldn't know who's liable, obviously, but in terms of strength of security, Redshift does allow encryption of data. So that's encryption in terms of communication to Redshift, as well as encryption of data at rest, whether it's snapshotted or it's live in the cluster. I think in terms of how strong it is, security, that question could apply to a lot of your cloud services out there. And requires, I guess, for healthcare data, may require a little bit deeper investigation, and it would be probably beyond the scope of what we've done so far. Let's see, if we go up to the third question, it says, can you mention what the width of the multi-billion record data set? Yes. This is a narrow table, so it's got, I think I have 4 keys and 1 metric. The 4 keys are integers, and the metric is decimal. So it's not very large, but it's representative of what a fact table would do. And given the extreme performance and the fact that it's only, I did this on the 2 and 4 nodes, we could always increase the number of nodes if you have a wider table, or you'd need more time to process it. So obviously, if you have a string table, it would take a little bit more time to process it. And then, see, going up, the second question, what is the annual cost of using 2 terabytes per year? Can I schedule secure auto data loads into the database remotely? So the first part of that is 2 terabytes. That would be 1 node, and if you do the 3-year commitment, that would be $2,000 per year. If you do by the hour, it depends on, well, 1 node would be, I think, 85 cents per hour, if I'm not mistaken. And then if you do a 1-year commitment, it's a little cheaper than that. But at the, I should mention, the $1,000, that includes upfront cost per terabyte, and then ongoing usage cost. And the second part of the question, I believe we answered that. So yes, you can schedule secure loads off and on the server. First question, what are the top 3 benefits Redshift has over Vertica? So I've looked at Vertica a little bit. We haven't done a POC on it. So Vertica and Redshift are both columnar databases. What I seem to hear about Vertica is it has problems updating data, and it seems that Redshift has overcame those issues. The other thing with Redshift is it's really easy to maintain and launch because it's cloud-based. And I think Vertica could be launched locally. I'm not sure about if they have a cloud-based service offering or not. We have several tools that we're evaluating as part of Big SQL. Right now, Vertica is not on our roadmap, but we could look into that and maybe put that on our roadmap. Let's see here, the security layers. So Jim talked about that, and if you do have additional questions, maybe that could be something we could take offline, to where we could do additional investigations and drilling into the security layers and the questions. Let's see, question number 6, I believe. I was distracted a bit, but I need to know if the platform uses indexes. Okay, so yeah, this is a good question. This is the benefit of this tool, is that you don't have to build any indexes, and in fact, you cannot build indexes. But as far as design, you do have to design your sort keys and your join keys, but you don't have to worry about indexing. The service does it in the background for you. And then next question, how is the data protected from hackers? Again, this goes to security, and I believe we've answered that. And does Redshift have any dashboard capabilities? If so, okay, so that dashboard, you mean analytics to the business users, not dashboards about the performance of the system. And if so, Redshift itself is not a dashboarding tool. Redshift is a database tool. You would connect a dashboarding tool to it, either via native connector, such as what Tableau offers, or via an ODBC connection if you didn't have a native connector. With ODBC connection, it's a little slower, but to keep in mind that when you're running analytics against Redshift, you're returning aggregated data. So most of the work is done on the server versus on your client tool. And last question: since SPs are not allowed, how do you defend against SQL injection attacks? I believe Jim alluded to that. It's so the way you're running the scripts is via a controlled ETL mechanism, and so you're not going to surface. And I believe the question refers to what if you had a live system like a website that's connected to Redshift. Well, one thing to note is that Redshift is not. You wouldn't use Redshift for producing or for I guess e-commerce sites or other public internet sites. What you're using it for is as an analytics system, mostly internal to your organization. Maybe you could even surface it to external clients, but you'd have to do it via a tool like Tableau or something else, and those would protect against SQL injection by default. But you're not. This system is not designed for, or this database is not designed to support OLTP style applications. Let's see. Does that clear up all the questions? Anybody else has any follow-ups or anything else they'd like to talk about? Jim, was there anything else you wanted to add or any questions you noticed as you were facilitating the Q&A?
No, I think we covered everything that everyone's asked for so far.
Okay, well, thank you all for attending, and looking forward to seeing you on our next webinar.